In this video, we're going to talk about continuous probability distributions. And the two graph examples that we're going to talk about in this chapter are the normal curve, which is our next video, and this rectangle, which it's hard to say rectangular curve, but that's technically what we're talking about. This guy, which is what we're talking about in this video in particular. All right, so what happens is that, as we know, continuous means that you get all the weird decimals, fractions of a second. So let's think about this as wait times. You go to a local sandwich shop and you place an order, okay? And as we know, typically it matters, did I go during a peak time? Did I go when no one is there? So I'm gonna get my sandwich faster. Are there employees that we prefer over others that work faster or slower? Okay, so typically when we're talking about wait times, you're probably going to have more of this example. However, in the book, they like to use wait times in this example. So they are saying that it doesn't matter what time of day I come in, when I place my order, who's working the counter. Am equally likely to get it from this moment in time to this moment in time. So let me go ahead and do the example that is in our notes. And this one is 6 is one side, 14 is the other. Here's our curve. And then this has a height of 0.125. Got ahead of myself. Okay, now, what's happening is that they're saying it doesn't matter, again, what time I go in, it will take somewhere between 6 minutes and 14 minutes to get my sandwich. Okay, now you may be wondering, how did they come up with this height over here? Okay, so if you take this, 14 minus 6, right? This is a distance of 8. This whole curve needs to equal 1, this area needs to equal 1 or 100%. Okay? So, to figure out the height, what they did is they said, oh, okay, well, if the area equals 1, and I know that the length is 8, okay? Okay. So if I set these two equal to each other, and of course this is 8, then what would happen is we would get 1 equals 8 times h. H would be 1/8, which is the same thing as 0.125. All right, awesome. Okay, so here's how this works. If you want to find the probability that your sandwich is going to take between, let's say, 10 and 14 minutes, okay? So I'm going to go ahead and write that. I want to find the probability that it takes between 10 to 14 minutes. And another way that we write this is using inequality notation. Okay, so you could write it either way. What this translates to is to find the area of our rectangle from 10 to 14. So if we come over here, let's see, 10 would be right around here. So I want to know the area of the shaded region. Okay, well, we're just doing the area of a rectangle. So the area of a rectangle is the base times its height. So its base would be 14 take away 10 is a base of 4. And we already know its height. It was given in the beginning in the picture, 0.125. So my area is going to be 4 times 0.125, which is the same thing as 0.50. So they're saying, according to this, I have a 50% chance that when I go to this particular sandwich shop, I'm going to wait between 10 and 14 minutes for my sandwich. Bummer. Okay. If we want to repeat it for different values, let's say that you were in a hurry. So you were like, oh, how long is it going to take me to get it between 6 and 7 minutes? Okay. So if we want to find this probability, what's the probability that we wait between 6 and 7 minutes? The area of this little slice, well, 7 take away 6 is 1. The height is 0.125, so it looks like it's going to be 12.5% chance of waiting between 6 and 7 minutes. All right, cool. Now here's one thing that might blow your mind. You might be thinking, well, could I get it in 5 minutes or less? The curve doesn't exist at 5 minutes or less. So what that's telling me is that no, you got a probability of 0 of that happening. So this is assuming that all the events that are possible to occur are the graph that I'm seeing. So getting my sandwich in less than 6 minutes or more than 14, according to this model, are not going to happen. All right, good luck.